Alright, so we're ready for section 11.3 on solving quadratics with the quadratic formula. You may notice we skipped section 11.2. That's on using what we call completing the square. You may remember that technique from high school. I think it's a great technique if you are maybe a math major to actually use it to prove that the quadratic formula works. But for the general population, it's definitely not needed. You can always use one of these other techniques to solve a quadratic. So we moved on to 11.3 on the quadratic formula. Just to remind you, the quadratic formula, maybe I'll write it up here, basically tells us if you have a quadratic equation in the form ax squared plus bx plus c equals 0, then you can solve for x with negative b plus or minus the square root b squared minus 4ac all over 2a. I'll remind you how I like to do these just to break it up a little bit. I like to find what's called the discriminant first. The discriminant is the part underneath the radical, the b squared minus 4ac. Again, that will tell you what kind of solutions you have. If the discriminant is positive, you have two real solutions. If the discriminant is negative, you have two imaginary solutions. And if the discriminant is 0, you'll have one real solution. Well, in fact, look at all three of those cases. I've picked out a selection of examples to do from this page. The others I'm going to leave to you. And again, all the answers are on the next page, I believe. The next page of your notes has these same equations written down with these solutions. Not the work, though. But it's great to try to do the work, try to get the correct solutions. Now, you might ask, well, why didn't you do one of the first ones? If you look at this equation, I probably wouldn't even use the quadratic formula on this one because it is easily factorable, right? If you were to solve this one, you would probably say, well, negative 8, I can find two factors of negative 8 that add up to 2. And I would probably say, well, this is just, v minus 2 and v plus 4, right, equals 0. And your solutions would be whatever make the factor 0, 2, and negative 4. 2 and negative 4. So if it's easily factorable, I probably wouldn't use the quadratic formula. However, you could. If you wanted to, you could use the quadratic formula and you would get the exact same answers here. Now, if I look at number 4, it's probably also factorable, but because the coefficient of the squared term is not 1, it's a little harder to factor. And if I get one that's a little harder to factor, I prefer to use the quadratic formula or some other technique. But notice there's an a squared and an a, so we can't use the square root method. And there's a coefficient of a squared that's not just 1, which means I'm left with probably using the quadratic formula. This one I think is factorable, but it's not easy to factor. So your a, b, and c, your a is the 2, your b is the negative 1, and your c is negative 13, right? So I like to find the discriminant first. I'm going to start with that. So I have enough room, I'll do that over here. So b squared minus 4ac. Well, what is that? B squared would be negative 1 squared. Well, that's 1. 4 times 2 times negative 13 goes here, right? So let's see. 4 times 2 is 8. What's 8 times negative 13? 8 times negative 13 is negative 104. So I have 1 minus a negative 104. So that's 1 plus 104, right? Let's make sure. Oh, you know what? I messed up severely, didn't I? What did I do wrong? Think about it for a second. This is not in the correct form, is it? This 2 is not a 0. So this is not going to work. And this is a common mistake, so it's probably a good thing I made it. And maybe I might even have done it on purpose. But we have to subtract the 2 first before we can go through this. So 2a squared minus a, we subtract the 2, we get a minus 15 equals 0. Now it is in the correct form, and my a is actually 2, my b is still negative 1, but my c is not negative 13, it is negative 15, right? Alright, so let's just change this to negative 15. Now we can go through what we were doing before. So if we have 4 times 2 times negative 15, that gives us a negative 120, not a negative 104, right? Now, 1 plus 120 then is actually 121, isn't it? That's our discriminant. That's the part that goes underneath the radical. It helps us break up the formula a little bit. So we have an a instead of an x, so I would say a is equal to, look at my formula, negative b, so negative negative 1 is positive 1, plus or minus the square root of 121, right? Square root of 121. Over 2a, a is 2, so 2 times 2 is 4. Alright, so if you said, well, let's just leave our answer like this, you would be short a little bit of where you need to be. Because square root of 121 we can find is 11, right? So this becomes 1 plus or minus 11 over 4. And so we can simplify that, right? We could do the plus. 1 plus 11 is 12, and divided by 4. 12 divided by 4 is 3. We could do 1 minus 11 is 10. 10 divided by 4, that's 10 fourths, which we could reduce to 5 halves, right? Oh, but that's a negative, right? Because we have 1 minus 11 is negative 10. Negative 10 over 4 is negative 5 halves. Those are our two solutions. All right, let's go to number 8. Let's see what we have in store for us here. Is it in the correct form, first of all? I don't want to factor it because I have an 8 in front of the square term. I don't want to use it. I can't use the square root method because there's an a squared and an a. So my last choice then is quadratic formula. In order to use the quadratic formula, I'm not going to make the same mistake I made last time. I'm going to move everything to the left and get it set equal to 0. So then I have 8a squared plus 6a plus 5 equals 0. So your a is 8, your b is 6, and your c is 5 in the quadratic formula, right? I'm going to decide again, find my discriminant, my b squared minus 4ac. Okay, that's the part underneath the radical. So b squared, 6 squared is 36. 4 times 8 times 5. Let's see what that is. I don't know. 4 times 8 times 5 is 160. So I have 36 minus 160 here, right? Ooh, 36 minus 160 is negative 124. So my discriminant is negative 124. That's the part that goes underneath the radical. So let's finish it off. So we have our variables a instead of x, so I have a is equal to. Formula says negative b. That's negative 6, right? Negative 6. Plus or minus the square root of the discriminant that I found was negative 124. All over 2a. A was 8, so that's 16. Alright, so what can we do now? Can we simplify it? Well, we need to see if 124 has any perfect square factors, right? So let's try to find some perfect square factors that go into 124. It's even, so it's going to be probably maybe an even perfect square, maybe not, I don't know. Let's try 4. 124 divided by 4. It goes in, right? So 31 times, and 31 it's a prime number, I think, so we can't do anything else with it probably. So let's take out a perfect square factor of 4, basically. So I'm going to rewrite this. A equals negative 6, plus or minus. Now I'm going to try to manipulate this a little bit so it's simplified. And so maybe I'll do this up above here, square root of negative 124. First of all, the negative we can take care of by bringing out an I, right? 124 I just said 4 goes into it, right? So I could write this times the square root of 4. And 4 times 31 is 124, so times the square root of 31. So what does that make this? Well, the square root of 4 is a 2. Usually that's written in front, so I'd have a 2i times the square root of 31. Alright, so that's what that ends up looking like. We have the square root of negative 124 becomes, in a simplified version, 2i square root of 31. And then we're going to divide by 2a, which is the 16, right? Alright, so here we are. We have this answer. We've done a lot of work already. We think we're done, but are we done? Another thing to check for is, do we have any common factors in all three of these terms? And we do, right? What goes into all three of these? Well, 2 goes into all three of those, right? So we can factor a 2 out of all of them. We basically factor 2 out of the top and 2 out of the bottom and cancel. So let's see. I'm going to write that down. So I'm going to factor 2 out of the top, and that becomes negative 3 plus or minus. The 2 just becomes, becomes I squared root of 31. Factor a 2 out of the bottom, and we get 2 times 8, right? And then we can cancel those 2's. And then we have our answers, right? And maybe I'll write the solution set. We have a negative 3 minus I times the square root of 31 over 8, and a negative 3 plus I times the square root of 31 over 8. Now, if you want to save some time, I believe MyLab has the plus or minus feature where you could just write this all in one step, which would save you time typing a lot of stuff in. Okay, you could write negative 3 minus I, or plus or minus I squared root of 31 over 8. It'd be nice to just do that once instead of typing that whole big thing in twice. Alright, so put a circle around that. That one's done. Let's look at number 11. Alright, this is kind of an interesting one, I believe. Let's see. Notice there's an a squared and an a, so we can't use the square root method. There's a coefficient in front of the a squared that is not just 1, so I'm not going to try to factor it either. But I do need everything on one side. You might say, well, let's move it to the right because there's already 2 things there, but it's much easier to deal with usually if your coefficient in front of the a squared is a positive number. This is for me. I don't know why. So let's move everything to the left. That would give me a 3a squared minus 6a plus 3 equals 0. So your a is 3, your b is negative 6, your c is 3. The discriminant I'll find to the left, b squared minus 4ac. B squared negative 6 squared is 36. 4 times 3 times 3. That's 4 times 9. That's also 36. What's 36 minus 36? Well, that's 0. Your discriminant is 0. What's that tell us about our solutions? If the discriminant is 0, we're going to have one real solution. Okay? Because the square root of 0 is 0, and adding and subtracting 0 gives you the same result. So we finished the quadratic formula. We have an a instead of an x. It seems like all these examples I picked, a lot of them have an a, right? A is equal to negative b, which is positive 6, plus or minus the square root of 0. What's the square root of 0? Which is 0, right? Over 2a, 2 times 3 is 6, right? Again, adding and subtracting 0 doesn't do anything to the numerator, does it? So your a is just going to be 6 over 6, which is 1. We only have one solution in this case, which is 1. So that one was nice and easy. I like that one. Let's look at number 14. All right. Would I use the square root method? I cannot, because we have an a squared and an a, right? Can we factor it? Maybe, I don't know. But because there's a coefficient of a squared that's 4, it's going to be hard to factor even if we can. So I'm going to move everything to the left and use the quadratic formula. So 4a squared We subtract the a, and we have a minus 8 equals 0. It's in the correct form, right? And so my a value is 4, my b value is -1, my c value is -8. I'll find the discriminant at the side. B squared -1 squared is 1, minus 4ac, so 4 times 4 times -8. Let's see what that is. I don't know, use my calculator. 4 times 4 times -8 is -128. So 1 minus a -128. That's 1 plus 128, which is 129. All right. So let's try to finish the quadratic formula. A is equal to -b, which is -1 or +1, plus or minus the square root of our discriminant, 129. This tells us, by the way, we have two real solutions when your discriminant is positive. And we divide that all by 2a. 2 times 4 is 8. This is a nice, kind of a nice case, I guess, because square root of 129 cannot be simplified. 129 doesn't have any perfect square factors. So these are your two solutions. In fact, you could write the solution set in here. Okay. Or you could split it up and say your solutions are 1 minus square root of 129 all over 8, 1 plus square root of 129 all over 8. All right. We have one more of these we're going to do together, and again, I suggest you do the rest of these for practice before you hit the homework or the final exam. Is it in the correct form? Well, let's talk about those other methods. Can we use a square root method? We have an x squared, and we have an x. So no square root method. We could maybe factor it, well, but if we factor it or use a quadratic formula, we have to have everything on one side set equal to 0. So let's do that. Subtract 1, right? We get 4x squared plus 4x. Subtract 1, we get a minus 9 equals 0. So you could try to factor, but if there is a coefficient in front of the squared term that is not 1, it's hard to factor, even if it's possible. So what are we going to do now? Quadratic formula, right? So I like to find the discriminant first. B squared minus 4ac. B squared, 4 squared is 16. 4 times 4 times -9. What is that? Let's see. 4 times 4 times -9 is -144. So 16 minus a -144. That's 16 plus 144, which is 160, right? Your discriminant is 160. Alright, so let's finish the quadratic formula. Your variable is x. So x equals a -b, that's -4. Oh, by the way, your a is 4, your b is 4, your c is -9, right? So we have a -4 plus or minus our square root of our discriminant, square root of 160, all over 2a. 2 times 4 is 8. And then we just have to see if it can be simplified. 160. Does it have any perfect square factors? Goes in 160. You know what? 16 does, right? 16 is a perfect square. In fact, if I want to simplify square root of 160, maybe I'll do that down here. Square root of 160. I could write that as the square root of 16 times the square root of 10, couldn't I? And 16 is 4. Square root of 16 is 4, so we have 4 square root of 10. 10 doesn't have any perfect square factors, so that is simplified, right? So this becomes -4 plus or minus 4 times the square root of 10 all over 8. And guess what? We can take a factor of 4 out of all three of those terms, right? Basically, we factor 4 out, we get a -1 plus or minus square root of 10. We factor 4 out of the bottom, we get 4 times 2. And the 4's cancel, right? So we end up with -1, x equals -1 plus or minus square root of 10 all over 2. So that's your solution set. And again, I don't have room, otherwise I might show you how to split it, but we've done several examples of splitting it up. You could probably do this in my lab. I think I've checked that before, and this is perfectly fine. This basically says we have two solutions, one where you do negative 1 plus square root of 10 over 2, one where you do negative 1 minus square root of 10 over 2. Alright, that's it for Chapter 11, and that's it for this course, actually. So, Math 105 anyway. Unless I use this video for some other class, we are good. And so we're going to stop here, and good luck with all your homework.